Well, now let's look for a formula that will help us determine how many ways you can do something that consists of two tasks in a row. Okay, we're going to do, let's go back to, for just a minute, let's go back from the previous video. You probably caught on to what the formula would be here. If you had 3 pairs of pants and 2 shirts, how many outfits could you make? 6. And you probably realized that all you need to do is you had 3 choices for the first one, 2 choices for the next, the shirts. All you have to do is multiply 3 times 2 and you get 6. In the next example, we wanted to go from city A to city C. You have to go from A to B to C. Well, city A to B, there were 3 roads. From city B to city C, there were 4 roads. So 3 times 4 gives us 12 possibilities for doing, I'm going to call this task 1, going from A to B, and task 2, going from B to C. Task 1, there were 3 possibilities. Task 2 had 4 possibilities, so the total number of possibilities is 12. And you can see that also from this tree diagram. So now let's fill this blank in. If there are m ways of doing task T1, m is a number, and there are n ways of doing task 2, then there are how many ways of performing task 1 followed by task 2? That's like going from city A to city B, that's task 1, and then from B to C, that's task 2. Remember, we just multiplied the numbers? That's all we have to do here. There are m ways of doing the first task times there are n ways of doing the second task. That's it, as simple as that. All right, let's look at another example. A library wants to display 1 large book on the top shelf and 1 small book on the bottom shelf. If there are 45 large books and 50 small books available, in how many ways can the books be selected to display? If you were drawing a picture, you might have something like top shelf, bottom shelf. How many ways can we do task number 1, putting something on the top shelf? Well, the top shelf is the large book, and there are 45 ways. There are 45 books, so you could do that task in 45 different ways. If you had 100 books, you could do that task choosing one of them and putting it on the top shelf in 100 different ways. Then we've got 50 small books for the bottom shelf. So we're going to choose 1 out of this and 1 out of this. So there's 45 ways to choose the book on the top shelf, the big book, and 50 ways to choose the book for the small shelf, the lower shelf, the small book. Sorry about that. And let's see what this is. 5 times 45 is 200 and what? 5 times 45 would be 200 plus 25, and then add the 0. Let's see, 50 times 50 would be 2,500, and that makes sense. So this is the answer. So that's a lot of possibilities. Imagine if you wanted to list out all of the possibilities. You need a big book and a small book. B1S1, B1S2, all the way to B1S. How many small books were there? 50. That's an S, 50. So that's 50 ways to use book 1. Then you got to go to book 2 and use small book 1. Big book 2, small book 2. All the way to big book 2, small book 50. And you have to go all the way down to big book, there were 45s. Big book 45, S1, all the way to big book 45, S50. So I used dots, these ellipses, but I represented the 2,250 possible ways. There are 50 ways using book 1, 50 ways using book 2, all the way down to book 45, 50 ways to do that. So it would have been difficult to write them all out, but this is kind of a representation using the ... notation. All right, now, coins. We are going to need to become intimately familiar with coins and working with coins. When you flip a coin, it either lands on the heads or the tail side. So there's 2 outcomes possible when you flip a coin, either heads or tails. So we're going to toss a coin 3 times. Toss one coin 3 different times. So we'll flip it, we'll observe whether it's heads or tails, we'll pick it up, flip it again, and we'll observe heads or tails, and we'll flip it again and do the same thing. How many outcomes are possible? Well, if you break this down, how many tasks are we doing with that one coin? We're doing 3 tasks. We're basically flipping it once, we're flipping it a second time, and we're flipping it a third time. So 3 tasks. How many possibilities are there for the first one? How many outcomes when you flip a coin the first time? 2. How many possible outcomes are there for the second time? 2. How many outcomes are there for the third time? 2 equals 8. Now, how many of you thought initially the answer was 6 because you're doing it 3 times and there are 2 possibilities for each one? Well, you don't multiply 3 times 2. There are actually 3 tasks taking place here. You could call this task number 1, that task number 2, task number 3. How many outcomes does each one have? 2. Multiply all those numbers together and you get 8. Since it'll only take a second, I'm going to write out, well, it'll take 20 seconds, say. I'm going to write out all the possibilities. You can verify that there are 8. Let's start with heads, heads. Sorry, heads, heads, heads. H, H, T. H is heads, T is tails. H, T, H. H, T, T. If you notice, that's all the possibilities that start with an H. Now I'm going to start with a T, and I'm going to repeat these 2 columns here. T, H, H. T, H, T, 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 H, and the last one is T, T, T. So the first one up here represents 3 heads. This bottom one represents 3 tails. And then picking one random, say this one, it's getting a heads on the first flip and then a tails followed by another tails. That's completely different than getting tails on the first and then the one heads and then tails again. So count them all up and you get 8 possibilities. Drawing the tree diagram, you always start in one state. Now let's look at task number 1, task number 2, task number 3. That represents flipping a coin the first time, second time, and the third time. So we have exactly 2 possibilities. Heads or tails for the first one. And then once you've received a heads for the first one, for the second one, you're either going to get another H or a T. Same for here. H or T. Now we've got 4 possibilities so far, but we got to flip one more coin. So I'll label heads, tails, heads, tails, tails, heads, tails. That's our tree diagram. And once again, see where I wrote all of these out? Let me just pick one. Let's pick this. Which path represents HTH? Which path in this tree going left to right? HTH means we go from here, we'd go H first, then a T, then an H. That path is HTH. And you can see the top one is H, H, H. The bottom one is T, T, T. Just taking this path. And this one would be T, T, H. Well, I've written out this many, I might as well continue. H, H, T. HTT, THH, THT, THT. And I think I've got all 8. 1, 2, 3, 4, 5, 6, 7, 8. So we are going to be looking for formulas on how to count things. We're not in general going to be writing all of them out and then counting them, or drawing a tree diagram and counting them up that way. We're going to try to use formulas, but if you have nowhere, you can't think of where to start counting, sometimes it helps to just start writing out the possibilities or to draw a tree diagram. It'll give you a clue on which formula to use, or it'll give you a sense on how to efficiently count the number of things that you're asked to count.